for today's session, it's going to be pretty lightweight. So I'm just going to have a few slides to walk you through like what's motivated for me to build something like this. And then probably like I'll take through a demo, running through my old script of demo script is available in public for you to go back and try again. And all the things that I'm going to show today are tryable from your laptops, which means that it's something for you to get started on doing real-time analytics and other stuff, right? So before I get started, I just want to understand like how many of you are familiar with the ADA terms, jargons. Probably I just do a quick refresher, like there are a few people around here. Start with the leftmost one, right? So what I'm talking about, what is basically a data stream, right? That's the basic unit of things that flows through something. For example, I have some examples put down there, an order, an user, employee, and all these stuff, right? So it's basically the data that gets collected from different sources, combined in some format. For example, let's take JSON as an example, and then it keeps flowing on all the stuff, right? That's the basic data stream, right? And once a stream as such is useless, right? For example, let's take the same data, water from a river, right? Unless and until you take it back in a bottle or something back to go and drink, it doesn't make any sense, right? As the water keeps flowing. It's exactly this paradigm here. Like if it's not an event, then the data in a stream is completely useless. Another way I could put that, data in isolation is always useless. You have to use the data in some or the other format. That's where the whole event thing comes into picture, right? What is an event basically? For example, I have two examples there. Joe joined Acme as a developer on some date. Order for 2 pizzas placed at 12 p.m. So these are something called as event. Right? Basically, when you talk about event is nothing but where it's a digital record of something happened at specific point in time. Without time, there is no analytics, right? So always time and analytics go with each other. So that's exactly what event is thing. When we combine these two things together, there are two entities involved. One is an event producer, somebody who basically produces an event that I'm going to use for. And that's going to be somebody called as event consumer who's going to basically consume these events and do some processing, right? For example, with these two records of events, like I can do little analytics, like how many people place 2 pizzas at this time, right? What all the pizzas they placed every 12 p.m. of the day, right? From which all the pizza huts or pizza houses that basically serve these pizzas. Those are something which you can draw little analytics from this, right? Unless and until it is not an event, I cannot do any analytics out of it. So that's a very basic thing about it. The event producer to an event consumer. And the whole thing put together is what is called as an event-driven architecture, which means that I'm going to use events to build application, build real-time analytics, dashboards, visualizations, you name it. So you see some visualization using Streamlit today. So I think how do we do that? That's exactly what is all about event-driven architecture. But on an event-driven architecture, there are multiple components involved. So that's what the very basic things that we are going to see. The very first thing, obviously, you know this. So when I talk about streams, it's all about Apache Kafka, right? Every day we talk about streams, it's all Kafka, right? So I'm just put down some information about Kafka, the key capabilities, stream, store, and ship. One thing we want to keep in mind is Kafka is not a database. So which means that it can store, it can have persistence, it can have data retention, but it cannot be treated like a database. So that's where all we are going to stream the data to some other system which can take the data and process the data for you, right? So other things like other two cases, the real-time analytics is what we're going to see today on the use cases, event-driven architectures, we talk about that, microservice communication when I want to do other two-phase commits and all these things, how do you event-driven consistency, log aggregation, and stream processing. So these are the very basic use cases of Kafka. So this is a very fundamental component of your whole driven architecture. Again, it's open source under Apache, which means that it's all usable right away from there. I'm going to introduce another little streaming database. Obviously, we can also use streaming from Kafka as well, but I found this one is much more intuitive because I'll tell you why I used Rising Wave. It's another OSS project that was born down. It's written in Rust. It has lots of, for example, I've given you some key stats. And the other thing, like why I come back to the point why I'm using Rising Wave here is because I'm take the data from streaming, for example, from Kafka, and I have to do some processing of the data. Technically, in a way, like collect the data in a tabular format or any other thing before I send it to my analytical engine, which is going to be Snowflake and Streamlit in this case, which is going to process the data. So Rising Wave is one thing that you can use here. The next one is like, all right, so I have data, I have collected the data, so I have to store data somewhere, right? So you can store in native table formats. For example, I can use Oracle database, or I can use SQL Server, or can you use MySQL, I can use Postgres, so you name it, whatever databases you want. But nowadays, the biggest need for people is that the data has to be queried by multiple engines, like multiple different engines. Like, for example, like I have to have open table format. which all the engines, SQL engines can understand, which means that you are not doing a vendor lock-in to a specific database server for that matter. And then this data gets stored in an S3 format, for example. I'm just saying in S3 or any kind of a format, a JSON format inside S3, for example, AWS in this case, right? Or it can be any other cloud storage for that matter. Processing engine agnostic, which means that I can have the same data, but queried from different engines, right? Which means that I can have the data created by Snowflake, but I can have the data queried by Trino, for example. I can have it queried by PostgreSQL if you want to do that way, right? And advanced table features. What I mean by advanced tables features is that one of the biggest drawbacks, or I should say a constraint with the native formats is that when I want to evolve the schema, when I want to change the table schema, right? In that case, it becomes difficult because there is no schema evolution natively available. I have to go back and change the whole schema, move the data across and do all of the stuff. With Apache Iceberg, what I can do is like I can natively change the schema dynamically. For example, let's say first stream gives me, first 100 streams or records of in the stream gives me a data in a particular structure. Then now I get a different one. Let's say I add another column to my table. I have a different JSON structure. Then this table schema can basically do the job for me, like on the fly, alter it, still store the data, still query the data without any issues. How is that done? Because all these things that is done by Apache Iceberg use something called a snapshotting, which means that I can query the data using snapshot IDs. Snapshot IDs are tied with specific schema thing. When I actually create the demo, I'll show you how the structure looks like, which it makes it easy for you to do this thing. It's not only that, it also allows you to do partition evolution. So we need to say like I can also evolve partitions. So I create a partition, for example, a query on a date, on a year. Now I get a lot of data on monthly basis. Now I want to do partition on monthly basis. Then I don't need to go recreate the whole partition scheme or move the data around. I can just go add a new partition, which basically queries by month. So it's that easy kind of doing partitioning, right? Our biggest thing of all is like snapshot-based time travel, which means that I can go back in history and get the data for example, you accidentally updated some records in your table. You want to roll it back, right? A specific period of time. Using these open table formats, what you can also go back, you can go back in a time and then take that particular record and insert it back. And performance optimize is super fast in reading. I'll show you some examples of that. And again, when I do a demo, an enterprise-ready governance is always there, right? Whenever S3 is just a storage format. Open table format is just for, in this case, for Amazon S3, or you can use Azure, or you can use GCP, whatever you want. The open table format is just a format of saving file, but the governance is controlled by the SQL query engines. For example, in Snowflake, I can define an Iceberg table and basically define the row and access controls that I want on this table, which could be controlled by it, right? And also the biggest thing, the biggest advantage I have seen with respect to Iceberg, I'll see about Polaris in a second, is that vending of credentials, right? In this case, I quoted that the data is getting stored somewhere in a cloud storage for that object storage, right? When I'm doing that in an object storage, what I basically need to have, I need to have the object storage credentials that needs to be shared. Usually what we do is like those credentials are always shared between multiple consumers, multiple clients. In case of if I use Apache Iceberg with Polaris, which is a REST catalog for querying the Iceberg tables, I don't need to share the credentials for it. The credentials are automatically vended, which means that the credentials are transparent to the client or the consumer, which means that I can keep adding clients and consumers without them knowing where the data is actually stored. The data can be moved across wherever you want based on your governance policies without affecting the actual query engines or the application that's basically querying the data. Second thing, it's also on a standard protocol, which means that I don't need to worry about any other new SDKs because it's going to be a REST API call, which means a Java, Golang, .NET, any client, Python, anything, you can just go do the REST calls on top of this. Decouple architecture, client server, again. So Polaris is something like which Snowflake contributed to open source, is right now in incubating. It's actually what is called a Snowflake called as Open Catalog, which is a managed version of Polaris, which we actually open sourced under Apache software license, right? So wiring all these three things together, this is the first thing, how do we actually do? Data streaming from Apache Kafka. Then I get a data. I'm just going to use a streaming database. All the streaming databases follow the same pattern, source and sink. There's nothing going to change. Source is the place where the data comes from. Sink is the place where the data drains in. And then I'm going to use Apache Iceberg in between to store the data, which is called as the persistence of the data. The stream data gets persisted, materialized, and persisted. I'm going to call that out there. And finally, we visualize using Streamlit. Streamlit is again an open source project, which is again acquired by Snowflake a couple of years back. So which is available as open source, which allows you to build interactive dashboards. It has widgets to build even AI chatbots as well, right? So we'll see the whole flow with the demo soon. But the main idea of building all these things together, this is I'm just put an example, like streaming, you can replace any streaming with whatever data you want. But the real problem, what happened is like when I want to take some enterprise tools versus ease of adoption, what are the problems that I technically face? The very first problem I faced was bloatware problem. So what I mean by that is, for example, if you take Apache Hadoop, and then I'm going to do that with any kind of an Iceberg table, even Hadoop can also be an Iceberg backend in between. When I want to do the icebergs and I want to containerize the old stuff, Iceberg alone comes for 3.5 GB of data, like the whole container size, which is not suited for your cloud native applications. All these applications, technically all these good tools technically bring a lot of bloatware into it. For example, I'll take a classic example. If you see the Raspberry Pi thing that you have a Linux that runs on it, and the Linux, the Ubuntu, the same Ubuntu version that you run on your laptop, and there's a lot of bloatware in, right? The same problem applies across. The second one is there's a developer experience gap. This is what most interests me. Why I actually build this is because when you want to try something like this, before even I can go talk to my organization about adopting a particular technology, I want to understand what is the implications of it, or what is the risk associated with it, whether I will be able to do it or not, right? Instead of me spending hundreds and hundreds of dollars getting these things on cloud, I can just try it on my laptop, and when it works, then I can move it to any kind of a platform, right? Again, as I told about laptop-friendly environment, cloud-native integration. So what I'm going to show today is all based on Kubernetes on Docker desktop, which means that you can simply move all these scripts back, which is going to into your any kind of a cloud platform for like EKS, GKE, or any other kind of Kubernetes platform where you can go and deploy. I'm very specifically on cloud native because we are AI data at Snowflake. I also want to share like how do we actually take these things into AI, into cloud, make them interoperable across. And time to value divide. So this is again a biggest problem that whenever we try something, any POCs or POTs that we do, or anything that we experiment at our organization, the biggest problem that we are facing is like, how do I go faster to market, right? For you to go to faster to market, first you want to nail down all the pros and cons of this particular technology or the stack that you're building on, and finally understand whether it's going to give me a value for the time, which is always a problem because there's a lot of configuration that gets behind any tool that you set up in cloud. So to avoid that problem, so you can just set up everything on a laptop, run your experiments, and if it all works good, then you go ahead with the next steps that you want to do. Expertise barrier, right? This is again a big thing, right? So when you come to a data company, for example, we have database experts, we have SQL experts, we'll have business analysts, and everybody, right? There will not be experts who basically does configurations, deploy Kubernetes, make all this. There might be people, but the expertise level will be like less compared to what your data company is. So what I want to do with this particular experiments is that this particular starter kit in another way is that you want to make people to just concentrate on what they want to build. For example, a data application, real-time analytics application, rather than sitting down and thinking about how do I deploy Kubernetes, how do I create my manifest, how do I deploy all my technology stack before I can actually start working on it. Again, this goes back to the time to value divide because the more the time you spend on all these things, the more larger the time is going to be there, right? Great. Testing versus production reality. So how many of you still believe DevOps has touched data world? No, DevOps touched data world? I'm repeating the question. Is DevOps applicable to the data world in other way? I think you're like me, like saying like, okay, it's not. But actually, it's where it's catching up. Data world did not catch up with DevOps because they're always a little reluctant. Now they are always catching up. So which means that the moment I start to write my first line of code till the production deployment, the platform or thing where I'm deploying should be technically same, right? It should not be the case that it works just in my machine kind of a scenario, right? It's applicable even to the data world because even to the schema changes that you roll in or even new data applications or visualization applications that you built in, everything has to go from your testing because you can see the defect technically seep from your development into your production, right? You can catch them right at development so that you can start fixing it so that again, going back to time value divide is going to increase your time to market much faster. Your new features are going to get into faster, right? So again, I told about the personal pain again, because I want to try something with Kafka plus Iceberg plus Polaris and everything put together. I was trying to find out like different tools, different cloud providers, different platforms. They're always having a pain because I landed up missing some kind of a configuration files or something like that. So I want to have some kind of a starter kit which gives you the get started thing and you can keep expanding on top of it. Democratization goal means to say like I want to have the governance and everything right from the start, which means that I want to have everything that you face on a real-time production scenario to be felt when you actually work on this particular one, right? I'll just skip few through things because just think about the time I have. Learning journey, again, focus shift. The focus shift is basically I want to concentrate on building the application, as I said earlier, rather than spending time on concentrating on how do I configure my platform, right? The same one again. So let me skip these two things to demo so that it makes things easy. So for this streaming data specifically, I want to apply like do not repeat yourself. Like just I'll take a scenario, right? When I was showing you that the data goes from a source to a sink, correct? That's how the usual streaming data that flows in. So if you don't use Iceberg for this, in this case, what happens is that I have 10 different sinks, and I have to write this code every time to drain into 10 different sinks. That's the biggest problem that I need to face. So I want to avoid that problem, kind of applying to not things, one source, multiple sinks. I don't want to do this, keep it simple and stupid stuff, which means that I just want to use SQL because that's the expertise as I have as a data company in my whole organization. I don't want a new DSL. I don't want a new programming language, or I don't want to do anything else for my data team to learn. That's another one here. Even better if it's cloud native, so natively built for cloud. And I can also build time series data because I'm building analytics, so which means that I need time series data out of the box. All right? Great. So let me quickly jump into the demo. As I said earlier, I have this old, let me blow this up a little. Is it clear at the back? So have the complete instructions of each and everything, starting from setting up your stack, and each and everything is documented there. This is publicly available. And the bit.ly link which I shared with you will take you to this particular document, which has everything for you, all the tools and projects that's used in this particular building this demo, along with a bunch of the other demos and other stuff. So what I've done at the interest of time is that I've created the cluster, and I've just set up Polaris as well. So if I go back to my cluster, and then let me blow this up a little. Okay. I'm just going to say kubectl get pods -n. I'll just say -n. Okay. Okay. So I have a bunch of pods running here. So for example, Polaris is where the Apache Iceberg Polaris is running here as your REST catalog. I have Rising Wave pods running inside. It's a single node one because I'm just doing on my desktop. And then I also have local stack running. I also have Kafka running here on my StreamZ cluster. It's a StreamZ Kafka that I'm using here, which is again an open source variant of running of Kafka on Kubernetes. So I have all these things running up here. So what I'm going to do next is very basic thing. And also I have this one. This is again local stack .local cloud. I think I forgot to add this to my thing here. Let me do this. Okay. GitHub. Okay. So local stack is nothing but an, you can think it like a AWS emulator locally, which means that I'm not going to create anything in AWS right now. Whatever the starter kit is going to use is going to give you zero cost, which means for all your experiments. So local stack basically allows you to kind of query any of the resources. For example, S3 is the only thing that I'm going to use in this case. There's nothing yet here because I've not created the catalog or anything else, which is going to create some bunch of files on this one, right? So let's go here, and then I've done the catalog setup. It gives you all the details, and then I have Ansible playbooks for you to go and set up this whole automation, which means that it also gives you what I call a head start into your organization. How do I want to automate the stuff within my organization? So you can also do the same stuff here. So with all the checks and other stuff. So let me skip this one and go to catalog setup. Let's do this. You can just copy this instruction right from here and then start running this. It's going to create an S3 bucket for me, and then bunch of other stuff, getting the token, creating the catalog, and all other stuff. So it can, again, making things simpler and easier for you. So I have all the catalog and other stuff created. So you should see the stuff right here. Let me refresh this to see this one. I have this particular catalog folder created, the bucket created. I should see some more files soon. So what I'm going to do next is kind of go and create some bunch of tables. So that's what I'm going to do. Again, you can go back here, create these tables right from here. I have the notebook already running in Visual Studio Code. I'm just going to run these ones quickly. Just this one. And then I'm just going to create the Iceberg version, retrieve the credentials because it's REST catalog. Going to create a catalog now. And then query it back again a REST API. Going to create a database, a leaderboard table. It's going to be a balloon game example where I'm going to have a leaderboard and other visualizations come up for you. There's going to be a bunch of statistics that I'm going to create. I'm just kind of going and creating the tables inside this. And then we'll get back to the time series one, real-time scores. That's going to get you the time series data, colored base pops. You will see how much data analytics we're extracting from a simple JSON record that you're going to see right now, and performance trends. I think that's pretty much we have. So once I have done this, so let me go to implement the pipeline. So I'm going to create sources and sinks. I'll show you the source and sinks once it gets generated. So you see here, I have a source and sinks created. Let me go here. Packages, okay, it is setup. And then you should see scripts. And then I have a sink and a source, right? This is basically two SQL statements. I'm kind of creating a source to insert into game events, which connects to Kafka to pull the data in a JSON format and start writing the records. These are all materialized views. Once the view is there and the source is there, basically I'm going to use this to sync into the database. So RisingWave basically uses PostgreSQL syntax for you to kind of create this materialized views, which is pretty much same as SQL that you talked about. So what I'm going to do right now is that I'm going to apply these two things. So that's what I'm going to do. If you see that, I'm just running another PSQL command to create the source. I'm kind of creating the materialized views. It's a time series data that I'm kind of creating right now. Once I'm done, probably I'm just going to create the sink where the data is going to be synced into Iceberg. Okay, that's the last one I'm going to do here. And bunch of sinks where the data is going to be synced. And what I'm going to do is that I'm going to generate the data. It's kind of streaming data. Just gives 2 minutes for that data to be generated so that we can see some analytics coming up there. So while this is happening, what you can also go back to see at local stack here is that it creates the catalog, it created the table, the bunch of tables that we created here. Every data is getting stored in something in a Parquet format. You can technically change any format for Iceberg, whatever format you want to store. And also you see the metadata getting created. Let's grab one metadata and then see what it looks like, right? So I'm just going to download this while that streaming happens. So you see this here, it instructs a schema here. So it's an array, basically a JSON schema. And then it has a default spec ID, partition spec and everything. And then it says like default sort ID, which sort order it needs to use. And everything is there here, right? S3, which S3 endpoint I need to have the data in and all of the stuff, right? Which means that whenever a query is happening, it's going to be high performant because it's not going to go search all your data folder. You're just going to go to the metadata folder, which has partition specs, starting and ending into it so that you can go query the data exactly. Technically, it's partition pruning done automatically for you. That's the reason why the data is the query in Iceberg tables are so faster, because it maintains all these things in a JSON format, right? Let's go here and also like what I can also do. Let's start getting some visualizations here. Task. I'm going to start Streamlit. It's just a Streamlit app. Let me see if Streamlit comes up. Yes, it's up here. Let me go to the home page and just do a refresh. You go. Let me go back and see if I missed anything. I think I missed one thing to create. Maybe let me go back to my thing. I think I missed out to create one table, color performance trend. It's created. I kind of create another file there. And I create this one as well. Things are all there. So I think probably the only one that was missing was this. Okay, that's fine. So let's go back and see if I get all my analytics data coming up somewhere. Goodness me, yeah. I think there is the leaderboard data is here. Probably this is the statistic that I'm doing live, kind of generating the data right here. And I can filter by people. I think this is all these things are created using Streamlit widgets, which allows you to do all this stuff right away in a very easy format. I think Streamlit again is open source one. I can also do something like a color analysis, where I basically do some color analysis on various players who are playing this particular game. The data is basically getting loaded here. Obviously, you can also play live if you want. And I can also filter by a player. For example, let's say I want to take this particular guy and see what this data looks like. I get how many colors is it, total balloon pops, the usage pattern, heat maps. All these widgets are given by Streamlit for you, which means it's so easy for you to build interactive dashboards. Some other statistics here, for example, by specific metric. Let's go do how many bonus hits this particular person has got. You should see all this metric again on bonus thing as well. So which allows you to kind of drill down on your analytics. Again, it's coming from the live streaming data that I'm kind of pushing it from there. And also, this also gives you some performance trends, a box chart. Basically, you read about the performance that you have, and also some other statistics about like the average score, min score, median score of all the players you are playing it, plus the average score by balloon color each player has taken up, and the time window summary, right? It all time series data using which I was able to generate all these things on the fly, right? I think that's pretty much I have. So if you want to repeat it, as I said earlier, this whole stack is doable. If you go back to this GitHub repository, which I have, the demo here, so it has a documentation which allows you to reproduce this completely on your laptops. I think that's pretty much I have. Obviously, we talked about the benefits. Again, I don't have time to talk about. I'll just leave with this slide in case if you are missed to take this documentation link where I have put on all the documentation for Streamlit, for all this whole stack that I have, which will allow you to set up all these things on your laptop. Thank you so much.